I welcome you all to the first Tech Talk as part of our department centenary celebration. My name is Ashish Kumar Mandal and I will be the moderator for this session. My entry year in the department is 1985 and I passed MTech in 1989 with specialization in instrumentation and control. My first job was with ITC, Tribunal Tissues Division. In 1992, I changed my job to Development Consultants Private Limited, which is DCPL. And in 2001, I came to Abu Dhabi and joined Tebodin Middle East Company. During my career, I have worked with Guljian Corporation US, Portals Limited in UK, Mapna Company in Iran, Tebodin Bilfinger in Abu Dhabi, and Parsons in Abu Dhabi. Right now, I am working with Ital Consult. It's basically a semi-government Italian consultant firm. And I'm principal engineer, instrumentation control, telecommunication, looking for the entire Middle East operation. My area of work is consultancy, design engineering, construction and project management for the field of power plants, water and infrastructure, chemical plants, utilities, and offsites. Our today's presentation, it is software-defined vehicle, and the speaker will be Mr. Dibyendu Datta. Let me introduce Dibyendu to you. I welcome Dibyendu.
Yeah. Just is my screen visible?
Not yet.
Not yet.
Coming.
Okay.
Yeah. This is the brief
Yes,
profile.
yes.
Dibyendu, I think everybody can see that.
Okay.
Yeah. Dibyendu is our alumni and he is living near Frankfurt, Germany for about the last 20 years. And he is fluent in German language. He can speak, read and write. His entry year in the department is 1989 and he passed out BTech in 1992 with specialization in instrumentation and control. His first job was in CFCL Holdia in plant maintenance, and then he joined ABB and moved to Bangalore. He's the first person in ABB who joined ABB Advanced System in Oil India Limited, Duliajan, Assam. Then he deputed to Taiwan for implementing DCS for CPC, which is Chinese Petroleum Corporation. After that, he migrated to customer business management of engineering and enterprise IT service organizations. He started off German operation of Emphasis, which is basically an HP organization, and he headed the business in the DACH region till 2012. He has worked with few big names in the industry, ABB, Bosch, Wipro, Emphasis. Presently, he is working with Tech Mahindra and heading the automotive and discrete manufacturing for Germany and Austria. On the personal front, he is married. He has only one son. He is doing electrical engineering in the Technical University, Munich. And Dibyendu loves traveling very much. And he travels extensively in Europe and India for business as well as for leisure. Now, today, the presentation, as you know, it is software-defined vehicles. It's look little bit odd that what is software-defined vehicle? A vehicle, it can be defined by software. A vehicle, it can be guided by software. Seems impossible? We'll see when Dibyendu presents it. But before that, I would like to draw your attention, like for past 20 or 25 years, how the automobile industry or the automotive industry has evolved. And it is really a rapid evolution, which we can say a revolution. See, here are the salient features. If you compare a car, which is before 2000, maybe 20 years back or 15 years back, and a car now, a vehicle, we are going to have, like right now we have, with the fuel efficiency, very fuel efficiency is the most OPEX factor nowadays as compared to fuel price. Now we have improved engine, suspension, brake and tire technology. We have safety. We have airbags, crash-proof glasses, hands-free mobile, camera, all safety features equipped. Comfort against harsh weather, that is cooling and heating. In-car entertainment and communication, you have radio, TV, display. Driver comfort, you have cruise drive. You have adaptive cruise control, which is going to maintain equal distance from the car in front of you always when you drive and put it in adaptive cruise control mode. We have navigation technology, GPS. So we will not get lost anywhere in the world. And latest development, which has hit the market, it is green car concept. That is no fuel and pollution, no pollution almost. It is EV, electrical vehicles. And if we look a little bit towards business, nowadays, as of last year, the automotive industries, these are contribute 3 to 4% of total world's GDP. And in emerging market like India and China, it is around 7 to 8% of country's GDP. Of course, keeping in mind that this is the statistics of the post-COVID era, which is going to increase, going to come up very soon. With this, I'll pass on to Dibyendu, and I request everybody to keep your microphone mute and keep your mobile silent. When you speak, just enable your microphone. In between the presentation, if you have any question, please raise your hand, or you can put your question in the chat box with your email ID. After the presentation, we will clarify your questions one by one. And if time doesn't permit, of course, we will get back to you in your email. So please give your email in the chat box with your questions. So Dibyendu, over to you for the presentation.
Okay. Thank you very much, Ashishda, for the introduction and handing it over. And first of all, I would like to really thank across everybody from the department, especially Udayda and Debuda, who masterminded this idea of having a tech talk organized, and that was really great. So it's a pleasure, and it's actually an honor for me to do this kind of a presentation for you. Obviously, the subject, software-defined vehicle, is a little bit of a new subject, especially for all of us who are coming from the background of instrumentation and power electronics and this kind of a background. It's a little bit of a new subject, but I can promise you it's not new. We will find quite a bit of relevance on what we are studying, especially in the instrumentation as well as the power electronics field. So let's go forward, and then I'll take it up from there. So now, just going to the next slide. What are the current future trends of this automotive industry? So if you look at the automotive industry, where it is going to, and how where the directions are pointing to, the first thing which is coming up is about connected cars. It's about communication between the cars as well as the external infrastructure, which may be the traffic lighting system, or the road infrastructure system, the connectivity between that. That's one very, very important criteria or a field of development which is happening. Then comes autonomous driving. Autonomous driving, I think all of us are quite nowadays getting conversant with, because a lot of cars are coming up with, I won't say complete autonomous driving, but some partial autonomous driving. For example, Tesla and all Tesla company like Tesla claim that they have developed autonomous drivability, but that is still now not approved by FDA, and they can't drive it on actual roads. But still, they are coming up with autonomous driving. And what is autonomous driving? No human intervention is required, and so that the vehicle can drive by itself. Then comes shared mobility. Shared mobility, where it comes from is basically, it's some kind of a concept where you keep on sharing the vehicles. See, when the cars become autonomous and a physical person need not have to drive it, so you can actually call the car from your mobile and use it at your convenience and drop it somewhere, and then somebody else, the next person, can actually take that car away for his or her usage. So we'll come to that. I will go into a little bit more detail. And the last one is called is the electrification of the cars, which Ashish just referred to during his introduction. Electrification, obviously, it's about moving away from the internal combustion engines where we had this diesel or petrol as the uh, as the gas supply, but the cars are now coming up with electric motors there, and which are driven by batteries. These batteries are very high capacities, and a lot of research has gone into the battery technology like lithium ion and those kind of batteries. So a lot of electrified car are already in the market. And if you would have observed that, in fact, Tata themselves have launched some electric vehicles already. So let's go over to one by one some of the details. So, for example, connected vehicles, as I was mentioning, connected vehicles is about interconnectivity between the vehicles. Uh, with this, what happens is that it's a vehicle to vehicle communication gets enabled. So what happens with that is that, for example, you and me are driving, and you have passed through a certain area of the street, or a section of the city where there has been some kind of a congestion or some kind of a road repair going on. That actually my car can actually call your car because it has passed through that area, and then take the feedback from there, and based on that the navigation system will interact, or actually process the data and navigate in a different way. So that is a really a breakthrough concept which is currently going on. Then a little bit into the autonomous vehicle. Actually, I deliberately put this picture on the left side just to get ourselves. That means we are basically from instrumentation. I myself is from instrumentation background from the department, and so we have been seeing those instrumentation and learning about those instrumentation. And personally, in my initial life, I have been working very closely in instrumentation as well as control systems. So if you look at it, the autonomous vehicle actually are how it becomes autonomous. The basic premise of this is about sensors and sensor data. That itself is the building block of an autonomous vehicle. If you look at that picture, you will also find that wireless interface, video camera, lidar, then GPS, rear camera, ultrasonic sensors, odometry sensors. Then it has a central computer, then radar sensors. All these sensors and the sensor data are basically processed in a very high performance computer, which actually resides in the car itself. I'll come to that later on. And and that, with that processing and with an underlying software over it, that actually instructs the car to go in a certain direction, to move left or right, to which precise angle it should maneuver, that kind of a thing. And that is how this autonomous driving actually is developed. It's a very complex thing. It's not what it looks, or I'm saying in just a minute it looks to be easy, but it's not that easy, because it's a very complex thing. And the entire road conditions need to be graphically mapped, and in fact those have to be simulated for the car to react in a certain way, so that no accidents happen. So there is a lot of research going on, and a lot of activities going on, and lot of simulation related activities are going on. So those are actually going to the depth of the developments regarding autonomous vehicle, but we'll keep at a higher level this discussion. Now let's come to the what are the stages of automation. For example, previously, when level 1 was there was no automation. But right now, in fact, when we have there is certain kind of emergency braking system. For example, there is a certain obstruction which comes. A lot of cars provide emergency braking system, so that they call it the level 2 automation. Then comes the partially automated. Partially automated is what, in fact, just initial a few minutes back, Ashista was mentioning about this adaptive cruise control. maintaining certain distance between the front vehicle. So what it means is that you set your vehicles that it will maintain some 20 meters distance between the previous vehicle and keep it at a cruise control mode with that adaptive mode. So what your car will drive with continuous distance and maintaining that particular distance within the previous car. That's the longitudinal part, and then comes the lateral part. Say for example, there are lane keeping assist. So you have the lanes which are demarcated, and the car senses those lanes, and it doesn't allow you to move across, violate the lanes. So that's the level 3 of automation. That's a partially automated thing, I would say. And then comes the full highly automated, where the other things also is taken care. Say for example, you feed the car a data that I have to go to a certain location. It takes the data from your navigation system and processes and where it has to drive, and it drives by itself. And that's how the fully automate. And then the next level comes fully automated. But the fourth level actually requires little bit of driver intervention whenever there are some untoward incidents happening. But the fifth level is just you, as it is shown here, you read a book and the car drives you across to your place. So those are the levels of autonomous driving. Then coming to that shared mobility, which I was mentioning previously. So that's the part of the case CA. We spoke about connected, we spoke about autonomous. Now we are talking about shared mobility, which is S. So shared mobility is basically there has been a lot of research on a lot of market study made. In fact, the right side picture is a McKinsey report. Actually, if you look here, it's a picture from a McKinsey report. In fact, if you look here, it tells that, just one second. Okay, so if you look here, say nowadays the concept of, we have a car. In fact, whoever has a car, we'll use it for business, we'll use for commuting to work, for leisure, for vacation, for shopping, everything. But in 2030, what will happen is that the ownership levels of car will reduce quite a lot. And in fact, through your mobile, what's shown that in between, through your mobile, you can actually call a car whenever it's required. So if you are going to office, you call a car, a nice sedan car, and take it to office and then leave it. And then when you're coming out from office, you again call the car through a mobile, and it comes and drives you back home, and you leave the car. For example, you're going on a vacation, then you take a car which is of a different order, or for example, you are going for shopping, you take a different car, and everything is available to your mobile. And there are obviously, you would have seen nowadays there are car sharing apps which are coming up. People are coming up with cars, and there is a complex algorithm which runs how the car sharing happens. Say for example, somebody has booked a car for driving from location A to B, and in between your place comes, which is between C and D. So what happens is that based on that algorithm, it will actually tell you that this is the particular car which will be most comfortable and most suitable for you economically as well as time wise. So it gives you that car, and that car gets an intimation, and it comes to your place. The driver actually drives it to your place. So that kind of a shared mobility is really coming up at a brisk pace, I would say. And now comes the electric vehicle, which is the cases E, the last E of case. What is electric mobility? I don't need to explain much, because we all know about it. The ICs, the internal combustion engines, are getting gradually replaced with electric motors. And electric motors, and those are driven by those battery technology, the really high performance batteries. A lot of research is getting done in high performance battery technology, and how to hold their power and charge and for a longer period of time, and how to get it charged actually in a short period of time. So those kind of things are happening. And with that, one of the biggest advantages is that we are moving away from burning petrol, diesel, and this kind of things on the polluting, and also reducing a lot of pollution for the environment. So that was about the case, and what it leads to is basically the software defined vehicle. The actually the topic, what we are supposed to discuss and what we are discussing is about a software defined vehicle. So what is actually a software defined vehicle? Software defined vehicle is actually a vehicle in which the functionalities, the various kinds of functionalities can be enabled through a software. The configurations of the vehicle can be changed through a software. So what is it is that the hardware will remain constant. The features, the enhancements of the car actually continuously happens through software. So let me give you an example. Today, if you have already bought a car, or for example, 5 years back you bought a car, and that car didn't have a functionality of autonomous driving. Sorry, not autonomous driving. I would say cruise control. But after 2-3 years down the line, you always feel that why can't I have a cruise control in the car? If you would have bought a car 5 years back, then there was no way to bring in that cruise control inside the car, because it requires a major changes into the car system. So what happens with this software defined vehicle is that, for example, you want to have a cruise control, you just enable that software, you do a subscription for that through your car manufacturer, and these guys enable it for inside your car, and you start using that cruise control thing in your car. So that is the kind of utilities what it brings to the table. And obviously you can see this, all these cars actually get updated over the year. So so the software of those cars actually can be updated over the year. So from through this internet downloads, the software of the car gets uploaded, in fact updated. And with that, basically what happens is that you can have a better version of the car, a newer version of the car. Some features get enabled, some features get disabled, and that way continuous improvements happen. Now let's go to a little bit of a history. In fact, pre 2000s, the cars used to be completely hardware driven. There were no electronics or software involved at all in the car. So after 2000, what happened is that the cars became software enabled. How it became enabled? There were ECUs, which are called electronic control units. The ECUs got inside the car, and those were connected to various sensors within the car. And the ECUs used to be programmed. Those are basically the microprocessor programming, what we have done, what we learned in our college. Those kind of programming was done, and through that the car functionalities were enabled and disabled. And next from 2015 onwards, the development started with the software definition. So what it means is that in that software definition, so these ECUs actually got transformed into high performance computers there within the car itself, and all those sensors and everything got connected to the ECUs, and then after that it got connected to the high performance computers. And through that, so basically what was happening is that through computer programming only, you were able to control the functionalities of the car. That's what gets enabled. So now I wanted to bring a little bit more relevance into our scope of study, what we study. We are all quite conversant with IoT. In fact, we really we are uh, quite in depth with the IoT, because a lot of instrumentation, in fact, the complete instrumentation nowadays have changed, and everything has become internet enabled. In fact, a lot of with all the most of the instrumentation or the instruments what are used in process plants, chemical plants, and manufacturing plants, those are all internet enabled. So IoT devices they have become. So in the car itself, that is also there. So for example, vehicle to vehicle communication, that's all, and that's one part of the IoT enablement which has happened. Or for example, infrastructure communication with the traffic lights, with the road sensors, with other devices. That's I'm sorry, that's that's also infrastructure, that's also IoT enabled. Then comes predictive maintenance. There are various kinds of sensors and for monitoring the health and the performance of the vehicle. Or all sorts of sensors are built inside the vehicle, so that monitors, for example, the engine of the car, or the brakes of the car, or the tires, or for example, the door handles, or whatever. And this gives you an intimation whether some maintenance is required or not. So all those devices are IoT enabled. For example, driver assistance, the sensors, cameras, the lidars, and all those things, those are all internet enabled, so IoT devices. And obviously personalization, for example, the sensors help us in personalizing our vehicle itself. So so that's how the IoTs actually play a very, very important role inside inside the software defined vehicle. Then if you look at it, the last line what I've mentioned here is that 5G wireless. In fact, nowadays all our mobile phones are getting enabled with 5G. And in fact, this communication of IoT communication along with 5G brings in new capabilities in this automotive industry and to your cars. So those are actually the in-depth ones. We can go later on, but today we will be at a higher level of discussion. So now coming to what are the components of software-defined vehicle. I mentioned about it. The primary component is about this edge computing. This is a very high performance computer which resides inside the vehicle, and and the computational power is very high and very fast. The reason being that uh, in a car kind of scenario, in a live scenario where the car needs to push emergency brakes, apply emergency brakes, and this kind of stuff, so you always need to have the reaction times need to be really, really fast, within milliseconds. So this edge computer, or the high performance computing which remains inside the car, that's a very, very important component of this software defined vehicle. Then comes the ECU, electronic control units. These are little bit of an old technology, but still they exist and they are there. They reside inside the vehicles. So, and after that it comes to the sensors, various kinds of sensors, actuators. Then coming across to the HMI, human machine interface. Human machine interface here, you would have seen in today's cars, there are really TV or computer like screens available inside the cars, and you can see, bring in whatever you want to in terms of entertainment, as well as displays, as well as the navigation system. And then all this needs to communicate with each other, and there is a very huge network of communication which resides inside the car. In fact, one of the things which I was mentioning, there are it's actually a Wi-Fi network which resides inside the car, as well as cable-based network. And obviously a massive amount of software needs to be developed and put inside the car to function. Then coming across, what are the advantages of SDV? So what it does is that it helps improve the performance as well as efficiency of car. So because it can be always optimized, and the optimized can be done through programming. It's not through manual optimization. It can be completely through the real time process mapping, or mapping of the basically mathematical modeling of the performance of the engine. You can optimize the performance of the car, and you don't need to do anything. It's through a computer. It can be done through the proper software. Then obviously it comes to the enhanced safety feature, because there are so much of intelligence built inside the car. So the collision systems, or the cruise control, and this kind of lane keeping assist, all these features actually help in reduction of accidents to quite a lot, prevent risk of injury and death quite a lot. Then comes the personalization. For example, when you get inside a car, I'm just giving an example. Somebody is tall, very tall. He wants to, if he gets inside the car, then he has to adjust his seat to a certain extent so that his legs can reach the accelerator brake comfortably. And then if next a short person comes across and has to start driving, then the positions have to be interchanged. And all this can be actually programmed and set inside. So when you get inside a car, you can tell the car that it is me who is driving, and the car itself will adjust your seat position accordingly, so that you can have a comfortable seating arrangement. And then, as I think I mentioned previously also, one of the biggest features what comes with this software defined vehicle is over-the-air updates. If you see, I just put it in the picture. So it's a car company who is putting the updates on the cloud, and from the cloud, actually your car is getting updated. So new features can be added inside your car, just with a click of a button. So that's a very advantageous thing for all of us in coming days. Will become a very advantageous thing. Then comes obviously the reduced maintenance, and environmental benefits are obviously there. Let's spend a short time on what are the challenges actually when the car becomes such a actually it becomes a mobile computer kind of a thing. What are the challenges, or what are the issues which can come up? The data, the car and sensor data needs to be very, very high quality and precise. Otherwise you cannot go to this kind of a level of computerization or automation, that kind of a level. Then with the car getting exposed to the internet, there are always risks of cyber attacks. So that has to be carefully taken care of, and the fail-safe applications need to be created, so that if some cyber attack happens to your car, how does it behave in a scenario? So that kind of things need to be taken care. So then comes obviously for having all these things, there has to be new regulations, new standards need to be built up, because your car itself is becoming so intelligent. It has to be really the standards and the regulations has to be in place properly. So now we are coming to what actually is the future of SDV, and how does it relate to the case. if you remember at the starting of the presentation, I talked about case, which is connected, autonomous, shared, as well as electrification. So this is the trend which is going on, and how actually SDV is connecting to this case, which is the next gen thing. Obviously, with a software defined vehicle, there is a improved automation, there is increased automation, then there is a huge personalization which is possible. We talked about connectivity, vehicle to vehicle connectivity, vehicle to infrastructure connectivity, and this kind of things. Then the sustainability also increases. By sustainability, I mean with advanced powertrains and this kind of technologies, and the fuel efficiency obviously improves. And anyway, if you're going for electric cars, it doesn't matter also, because you're always trying to use renewable energy for this electric power. And and the last and final thing is about new business models really come up. What do I mean by new business models? Say, for example, in-car that entertainment. Today in a mobile phone, we try to download some app or something with some a small amount of money, which is quite which we like. Similar kind of thing, you can actually download inside a car some new functionalities you can buy from third party, not not the OEM, for example, Mercedes Benz or BMW, or for example Tata's or whoever. You can actually buy from a third party, and this third party actually can have that software, sub utility software built inside, and that you can download and use it for your car. So that's in summary about this software defined vehicle and its relevance to the case. So what I did is, I tried to bring in that, what actually is the next stages of development, or what are the upcoming trends in the automotive industry, as I told you, case, and how the software defined vehicle actually addresses the case and takes it. So it's a combination. I would say it's a closed loop kind of thing. Unless you have a software defined vehicle, you cannot achieve that case. All those four conditions what are required for case, and for case to get attained, you have to have a software defined vehicle. So that's what I just wanted to highlight today. A case of SDV. That's what I wanted to uh, today speak about. And I now hand it over to Ashishda for the next stages.
Thank you, Dibyendu. The concept or the overview of SDB, what you have presented, is really enlightened us. What I could summarize from your presentation in a lighter note, I'll just share. Say, initially we used to have, as you said, in the pre-2000, the cars which are driven by petrol and diesel mostly. Then in the market, it came like hybrid cars. It is very much there in the street. It's a dual driven, that is petrol, benzene or gas, or diesel or gas. Subsequently, it came electric vehicles. Then it is the era of software enabled, where with the help of artificial intelligence, the driverless vehicles came up. And lastly, the software.
আমাদের এই অপটিক্স এর পুরনো এই অপটিক্স এর মানে অ্যাপ্লাইড ফিজিক্স
Hello?
সমীর বাসু শিক্ষক আছে।
I think somebody is speaking. Okay. So, and lastly, the software defined vehicle. Now, Dibyendu was pointing out a feature, that is shared mobility. Just imagine that nowadays, in a nuclear family, many people of us, we have 2-3 cars, at least 2 cars, husband driving one car and wife driving another car. Instead, we have a car which is software defined with shared mobility feature. We have a mobile phone which is smart, maybe 5G enabled, and of course the car is driverless. So in the morning, you tell the car, okay, go to school and drop my kid. The car goes and does this. Next, you came up, you go to office and tell the car, go to home, pick up my wife go to the supermarket. Okay, it does that. So one car completely driverless, it is rotating throughout the day and performing all your social, family, your professional duties, and at the end of the day, you are going to garage the car. So one car is serving all of you. What is the advantage? The advantage is less number of car, less fuel, of course, less pollution, less traffic, better parking and road utilization. So this is upcoming. This trend is upcoming. And the positive features what Dibyendu highlighted, that is, if you have a car like this, no need to change the hardware. You only change the software, which is basically the manufacturer will put a cloud and it will update. The car is modular. You can enable or disable the function through software. You can add or you can disable on-demand functionality. So these are very, very interesting, features what you're going to have. And of course, the threats. The threats is electronic failure. Of course, we have to have a fail-safe design, redundancy, all what we read in our instrumentation control automation classes, and of course the cyber attack. So the specialists like Dibyendu, those people are working on this. There are a couple of questions. Before going to question, I'll just show you 2 slides. See, the development in auto industry today, these are the world leading electric vehicles. Tesla, GM, China is coming up, NIO, Volkswagen, and Nissan Indonesia. So already these things are in market. And for the leading driverless companies, we have Waymo, we have GM, we have Daimler Intelligent Drive with Mercedes-Benz, we have Ford and Argo with artificial intelligence, Volkswagen with combination with Microsoft, and Tesla Autopilot. Of course, Tesla up to now, they made a drive test in Arizona and it needs a human driver to monitor. And if we look a little bit about the business, I just pulled out one statistics for 2022. See, initially our automobile industry, it was subdivided into 3 major giants like US, Europe, and Japan. US like GM, Chrysler, Europe like Mercedes, Volkswagen, and Japan like Toyota, Nissan, and all these people. Subsequently, in the market, South Korea came up with Kia, Hyundai, and all these popular models, and of course China. So this is a brief statistics that in 2022, the revenues of different companies in million US dollar, and these are actually the positions. So the first position is held by Volkswagen. You can see German, Japan, German, US, German. So all top positions are acquired by mostly US and American company. And see, the China is coming. And of course, we are not way behind. Tata Motors India, we got 21 position in the last year. And of course, leading to Suzuki Japan. And before I end, the part where I'm living in Dubai. The driverless taxis are already on the road. And there is an app. It is called TXAI. It's just a reshuffling of the word taxi. Instead of TAXI, it is TXAI. Means taxi with artificial intelligence. You can download from Google or in your smartphone from Play Store or App Store, and you can book a car. And in the next year, it is planned that around 40,000 cars will hit Dubai streets. Dubai Metro is driverless. Dubai monorail is driverless. If you have visited Dubai and you have gone to Atlantis, the monorail is driverless. So the features are coming up. We are in a big way to achieve this SDV functionality, what Dibyendu has explained. I'll not spend much of your time. I'll go straight into questions. Dibyendu,
Yeah.
Mr. Devjit Mondal has raised his hand. Devjit, please unmute your speaker, and then you can ask your question. Devjit. Devjit, are you there? Okay. Mr. Siddhartha Sen Majumdar.
Thank you, Dibyendu. Can you hear me?
Yes, I can hear you. I can.
Thanks for your nice and enlightening lecture. And I have one two small query. Firstly, whether only software part you take care, or is it total solution you give? I mean, out of box solution, sensor, automation, and this software.
So, thanks for the question. In fact, it's a very good question. The thing is that it's a very vast subject. It's
Right.
what I told in a very short form. It's a massive subject. And to give an exact answer to your question, I don't think software and hardware and actually everything can be done together. But the OEMs, by OEMs I mean, for example, the Mercedes-Benz or the BMWs or for example the Volkswagens. This kind of companies actually are doing this. So there is
Right.
They have their own software, and some statistics and data. Because you raised this question, thanks for that. I would like to put you across. Previously, in car development, automotive development, it used to be mechanical engineers, electrical engineers, and those kind of engineers used to be part of that. But nowadays, in fact, in Germany, Mercedes-Benz actually has 5,000 engineers, software engineers, just for building up their cars. They have a system called MBOS. What it means is the full form of that is Mercedes-Benz operating system. In fact, that Mercedes-Benz operating system is what I talked about. In fact, the software-defined vehicle, the platform is called Mercedes-Benz operating system, and they are currently developing that. Similarly,
is it
for
out
trucks,
of the box solution? Everything can be given and customized. Is it like that?
Yeah, first time you have to develop it, and after that you can keep on customizing for various vehicles.
Okay. Thank you, Dibyendu.
Yeah. Thanks.
Okay, Dibyendu, we have next question asked by Mr. Ranjan Ghosh. Mr. Ghosh.
Yes, please.
Mr. Ranjan Ghosh.
I haven't asked any question. I just gave a thumbs up.
Oh, okay.
Okay, fine. Mr. Uday Banerjee, next question, please. Mr. Uday Banerjee. Dibyendu, Mr. Debashish Pal.
Yeah.
ভাই আমিও কোনো কোশ্চেন করিনি, আমিও থামস আপ দিয়েছি।
আচ্ছা, okay, thank you. Mr. Debashish Pal, is there any international standard for SDV?
There is a consortium which is working on that. Still now it is not developed or the standard has not come up. Still now it's happening in a very, very much distributed manner. But obviously there are all these big automotive giants are sitting together across the table to come up with some kind of a standardization. So this is in the process, but still now there is no proper standard which has come up.
Thank you all.
Okay, Mr. Debabrata Sarkar has raised one question. When you speak about the shared mobility, we have been enjoying similar facility through app cabs like Uber or InDrive, etc. Yeah. So the same facility will be available through driverless vehicle through different app, right?
Yes, exactly. So this shared mobility will actually be available in a driverless mode. So that's, in fact, I showed you one slide and one picture of that's a McKinsey picture. In fact, that is not my picture or anybody. That's McKinsey's reports picture. They tell that by 2030, in fact, 50% of the people will start owning their cars. They will go for this kind of a shared mobility. Today morning, let us consider a scenario. At 8 o'clock, I have to go to office. What I do is in my mobile, I tell that I need this type of a car, and the app brings the car to my house, and I go and go to office. Then I release the car, go inside the office, and while coming back, I again go to the app and tell that now I need a very good different type of a car because I have to go to an evening party. So a different type of a car comes to your office gate, and you take that car and go to your party location. So that kind of a scenario will be evolving, and that's the picture which shows which I showed in the first or second slide. So thanks for the
Dibyendu, I have raised my hand now, Ranjan Ghosh here.
Yes, please go ahead.
I was asking about, in addition to the standardization, the regulatory issues, especially in respect of the safety, cyber attacks and all those. Any countries working on the regulatory part?
Yes.
Working through this?
Yes. Ranjita, yes. Yeah. Thanks for the question. And in fact, you're actually right and exactly on the point. There are a lot of regulatory requirements which are coming up, and in fact, I showed in one of the slides that there will be a lot of regulations which will be coming in, and gradually that software. So in the software itself, there is a concept of hardening of the software, and the software has to be hardened and has to meet those kind of regulations before you can actually inside a car. So those kind of regulatory norms are coming up, and also you can understand that your car is actually exposed to the external world, which is the internet. So a lot of regulatory requirements are coming up, and a lot of things are also getting in place. In fact, it's not that nothing is in place. A lot of things are in place also.
And additionally, what is the status of the government of India's thinking about the regulatory issues? All these, any thing is going on that?
I think. In fact, or not. I think. In fact, I read a few times also. The aviation ministry is working on that. They're coming with some kind of a regulatory thing regarding autonomous driving and all those kind of these features what I talked about. They are already on the job. They are already on the job. Yeah.
I see. Thank you.
No, welcome.
Thank you, Mr. Ghosh. Dibyendu, we have a question from Siddhartha Pal. Siddhartha, are you? Hello.
Good evening, Dibyendu and Ashish.
Good evening.
Yeah.
Please go ahead.
It was a wonderful show. I have a very small question. I have seen one slide where you mentioned about the challenges. My question is, while operating a computer, sometimes the system hangs. So suppose a car is running with, say, 100 miles per hour, and in the middle of the road, if your software system hangs, so what is your precautionary or backup plan?
No, in fact, Siddhartha, it's a very good question, and I know where you're coming from. Obviously, that is there. You know, I forgot to mention, or maybe we didn't come to that depth of this discussion, because today I was just talking about the overview at a very high level, 10,000 or 20,000 feet level view of this software-defined vehicle. It's an enormous subject. We can go into every bits and pieces of it. But coming to your particular question, obviously there is a fail-safe mechanism built inside it. And this computer, the high-performance computer, what I'm talking about, it's not a single piece. There are actually 3 pieces there. So it's not, if one fails, the second takes over. If the second fails, the third takes over. So you can assume the kind of redundancy they built up into this one. You cannot leave a 100 miles per hour car just like that without control. So that's completely ruled out, and that's enough of protection is taken or care has been taken to make it fail safe.
Thank you, Dibyendu. I am quite satisfied with your answer. Thank you very much.
Okay, Dibyendu, next question is Mr. Sudeep Kumar Saha.
Yes, please.
Mr. Saha.
Yes. Good evening to all. And I have just question. Our Transport Minister Nitin Gadkari ji told that we will be having electric vehicle very soon. Any timeline, electric vehicle or SDV, any timeline at least in metro cities in India, what can be the anticipated target or timeline for the introduction of this system?
Uh, in fact, I'm also not very sure about the timelines, but I saw that Mr. Gadkari has announced that will be electric vehicles. But in fact, I saw some newspaper reports that Tata themselves have come up with some electric vehicles, Tata EV or something. And obviously, for having those kind of electric vehicles on the road, the charging system and those kind of infrastructure is getting built up. But so to say, the way the charging system is available in those kind of countries, developed countries, for example, USA, Germany, or European countries, I don't think it has not come to that level in India, but a lot of activities are happening. It should come in few years, I would say. In short time, it should come.
Hey, can
Okay,
I
thank
come
you,
into
sir.
this?
Thank you.
Electric vehicles are already on road. If you go to any Tata owned city like Jamshedpur or any mines of Tata's, all the vehicles they are now using is electric vehicles. And I have seen electric vehicles in Pune also and Calcutta also. So there are electric vehicles on the road.
And by the way,
I,
Uday, I have noted couple of electric charging stations in our city also. You have got the facility of float charges and boost charges. There are two things there. So I think it is on the road.
I just want to come in. Electric vehicle is almost. I live in Gurgaon, and in Gurgaon, electric vehicle you can see plenty of them. Even the charging stations. Every mall, thousands of malls are there. Every mall almost in their parking has charging facilities. So when somebody parks the car nearby, there will be charging facilities. Second thing is electric vehicle is very, especially two-wheeler, of course, is almost the delivery mechanism of Zomatos or all these. They have 70% of the two-wheelers are electric two-wheelers. In Gurgaon, I'm talking about. I don't know about other cities. And there are taxi services, which is called Blue. They are all electric vehicles. There's a new taxi services which has come up, which is electric vehicles completely. And there are every petrol pump has almost not every, but many petrol pumps has the charging stations. And Tata themselves are creating charging stations even along the highways. So that's happening. Nitin Gadkari's, initiatives are going in that direction. And another thing I just wanted to add in this is that the development of vehicle, the next generation of EVs are hydrogen vehicles. Nitin Gadkari himself uses a hydrogen vehicle, and there are some hydrogen vehicles are getting, some of the big companies are working on hydrogen vehicles also. Thank you.
Correct.
We are running short of time. Nirmal, can we exceed the question and answer session by another 5-7 minutes?
Okay, no problem.
Okay. Yeah. The next question, Mr. Sudeep, I think your question is answered, or do you still have something to ask?
No, yes, thank you. Lot of feedback I have got. Ranjan, Mr. Ghosh also has just now highlighted. I am satisfied. Thank you.
Thank you. Next question is Mr. Debashish Pal.
Hello, good evening.
Yeah.
Good evening, Debashish.
Thanks a lot to the organizers for this such a wonderful session. I am Debashish Pal. I have some relevant questions regarding this presentation. One is
please go ahead.
How electrified vehicle, that is how can it save the pollution. Basically, the electricity also getting generated in present scenario from the biofuels, and moreover for every step of transmission to charging, and at every stage the efficiency comes down. So I think it will not at all save the pollution. It will not at all fix or reduce our pollution status. And another is the thing. The next question is by how many years you expect to launch or successfully launch your SD in India. And the third question is what is the logic basically? We know that there are PID, there are fuzzy logics, and other logics which we imply in all the industries, that are the standard logics. And I want to know what is the name of that logic, so that we can know more about this about the study of this logic, what is going over the world. Can you please guide some name of the logics that is being implemented or that is in the stage of development? Thank you, sir.
Okay, Devashish, I will take that question one by one. You have put across three questions. The first question is about whether electric charging actually reduces pollution. The answer to this question is you are right. It is not reducing as on today's date. It is not reducing pollution, because anyway the electricity is produced by coal plants, or that means thermal power plants, or whatever. That those are creating their own pollution, and through that electric you are actually charging the vehicle. So that is a point. But remember one thing, I think I mentioned in the presentation also. All the electric, in fact, for example, Germany, where I live in, around I think the data shows around 50 odd percent. I think 53 or 54% of our electricity is generated by renewable means. There are these windmills, there are this photovoltaic cells, and then there are actually those windmills which are developed in the river, in the ocean, North Sea, which is north of Germany. Just 70 kilometers away, inside the ocean, there are windmills created. There is a huge 70 kilometers by 70 kilometers space. There are a flurry of windmills which are created, and that generates huge amount of electricity. So when you have the electricity generated by renewable means, then obviously it reduces the pollution. That's the answer to your first question. Your second question was what was that? Sorry, you have to help me out.
Tiffany, how many years it would take to
how many years it will take to
SDP?
reach that? See, Devashish, the thing is that it's already picking up shape here. In fact, in these developed countries, it's already coming to existence, and there are a lot of developments, lot of activities happening. And in fact, right now, I think I told you that there is just few minutes back I was mentioning about, for example, Mercedes-Benz. They are developing an operating system which is called Mercedes-Benz operating system. For example, Volkswagen, they have developed an operating system which is called Carrier. So these are the basic layers of this software-defined vehicle. So the high-performance computing are actually working on this operating system. So just to answer to your question, it will take a little bit time to come to India, but a lot of vehicles are getting imported into India. And mind it, a lot of development. So, for example, Mercedes-Benz I talked about, some 10,000 engineers are sitting in Bangalore, and they are developing that MB.OS for them here in Germany. So this is for your information. I think somebody raised a question: what you need to be expert on? Everybody needs to be a PhD to get working in this field, but it's not the fact. I think I'm answering that question also. That in Mercedes-Benz, for example, 10,000 engineers are there in Bangalore. They are working on this particular project. So you don't need to be a PhD to work in this particular field. I think it was Ved Prakash or somebody in the chat had written that question.
No, I think Dibyendu, I'm interrupting you. We have not finished. Debashish has got another question. He has got total 3 questions. Ved Prakash will come just next.
Okay. Debashish's last question was?
My last question was about the study part. What are the logics being implemented or in the state of development?
Correct. This is there are enough logics and innumerable things which are happening there, especially in the simulation, in the testing space. There are lots of development which is happening. I can provide you a list of that. Maybe separately you can write an email to me and I can go over, because it's going into the technical direction. I can share with you what exactly. See, it's not about logic. A car control. If an obstruction comes in front of you, you have to immediately press the brake. So the logic is quite simple here. It's not about that process control logic where the temperature is going down or up. You have to control the valve in such a way that it reaches that temperature. It is not that one, but the scenarios are very complicated here. So it's the logics are simple, but the scenarios are very complicated to explain you. And for creating those scenarios, it's not a very easy thing. How can you create a scenario where all of a sudden a stray dog is coming and running across the street? You have to create a scenario, because you cannot test a car inside, put it on the street and try to put across a dog on the street. You have to create a scenario like that. I'm just talking about some particular scenario. So these type of things are very important regarding the development.
Is this answers
Thank
all
you,
your
sir. Yes, sir. I am totally satisfied with all the answers, and I got all of my answers. And it will be helpful for us if you kindly share your mail IDs in our WhatsApp.
Sure.
Thank you, sir.
Okay, Dibyendu, next question. Raise hand. Raise hand.
I want to come in this regarding this question.
Ravindra, I'll come back to you. Let me take up the next question. Next question comes out in serial order. Is Ria Mandal. Ria, are you here?
Yeah, I'm here. Hi, good evening, everyone. My question is on a slightly different note. So recently, companies like Google and Renault, they have partnered to work on something called as a digital twin technology, where you have a virtual replica of a car and you assign the commands through the twin mode, basically. So how does this align with the SDV? This would be my question.
So excellent question, Ria. In fact, sorry to say that I think this is the first question from a lady, but absolutely great question. The thing is that I think you are slightly in this field, what I can understand. And in fact, I was trying to answer Devashish's previous question, giving him the scenarios, how those scenarios are getting created. Obviously, you have mentioned this digital twin, and I would like to spend a minute on this digital twin part. So, very, very interesting point Ria has mentioned. Digital twin. What is a digital twin? Say, first, the thing is that you have a car. It's a hardware piece, right? And I was talking of a scenario: a child running down the street, and you cannot create a scenario like that. A child running down the street to test your car, right? It's absolutely ruled out. So how can you do that kind of a scenario? So you create a digital twin of your car and create that scenario with emulating that particular scenario, and that is where that concepts of metaverse and all those things are coming into picture. Metaverse is what? It's a simulation of your actual a replica of the scenario where you're living in. And when this kind of digital twins interact with metaverse, then this kind of testings will be happening. And these are the latest developments. These are the high-end developments which are happening in this particular field. And Riyab, I assume I'm not sure if we had answered your question. Or
Yes, you did. Yes, you did. Yeah.
okay. Thanks for raising that. And in fact, I'm sorry that I didn't highlight on this particular point during my presentation or during the other things. But it is very, very good that you raised this point, because this is actually the main crux of the development which is happening.
Yes, right. And I think this is probably the future of SDV at the moment.
Right. Exactly.
Thank you so much.
We have two more questions from Mr. Ved Prakash Das and Partharaj Ghosh. But before that, I would like to take Mr. Ranjan Ghosh question. He raised his hand. And please, Mr. Ghosh.
Yeah, thank you. I just wanted to respond to Devashish's question. There are two parts of it. One is that whether the pollution is reduced by the EVs. This is a big subject, of course, because if as Devashish also has Dibyendu has mentioned already, that the power which is generated today is globally. The fuels, the fossil fuels are major part of average on the supply system. But so far as vehicle is concerned, if you take, suppose a power plant is generating 50 megawatt of power or 1000 megawatt power. Now that power is going to the industries, going to everywhere, and a fraction of that is coming for the charging of the electric vehicles. Now, if you see the per capita emission from a vehicle which is running on diesel or petrol, and vis-a-vis the fraction of the total power which is generated in one power plant which is polluting the atmosphere, it's very, very minimal. So if you switch over to electric vehicles, the specific vehicles pollution will be reduced a lot, even if it is generated by the fossil fuels. And as we grow, as Dibyendu has told, for example, Germany, the vehicles, this thing is changing. But still, even in Germany, most probably, if you consider this case, that the overall power generation and overall power generation and its impact on per capita vehicle, per vehicle, it's not comparable at all. Per vehicle, the pollutions being created is much more than the fractions which are contributing to the overall scenario of the pollution generated. So that's my one question, one thing. And second thing is, there's a question of logic which was raised. What is the logic system? Actually, today, the logics are not even the fundamental building block of the entire development. It's not. It's like when the integrated circuit was not there, we used to develop some electronic hardware which had like field effect transistors, and then use those field effect transistors. It switched over to a simple microchips, and it goes on. So that's what I was telling. The logic is, Dibyendu has already explained. Sorry for that. So that was my thing. Thank you.
Dibyendu, you'd like to add anything on Mr.
No. I think Ranjanda has explained quite clearly the things.
I'd like to take next questions because we are running out of time. Mr. Ved Prakash Das, you will get it on the chat box. You have partially replied to this, but I would just like to go through and reply to his question. Mr. Ved Prakash Das, you are here?
Yes, sir, I'm here.
Yeah.
Good
Okay.
evening, all.
Yeah, good evening. So, Ved Prakash, I think I was referring to your question in between when I was trying to answer another question. So I see that you're mentioning that this R&D centers, the employability will be only PhDs. It's not like that because there are lots of things which are there, which needs to be developed, and there are n number of things. In fact, at this moment, I just scratched the surface of this particular topic. It's a huge topic. It's a huge subject. It's not such an easy thing, I would say. And to answer to your question, it's not about only PhDs getting chance in this development process. There are a lot of other activities where the normal engineers like us also can contribute.
Ved has got another question. This is regarding guidance and real-time trafficking protocol standards, if there is existing in SDV.
There are certain protocols which are available, in fact, it's there. Maybe I can share. If you share an email, I can share those protocols with you.
Sure, sir. Sure, sir. Thank you.
Thank you, Ved. And next question is Mr. Partharaj Ghosh. Mr. Ghosh.
Hello. Good evening, everyone.
Hello.
Yeah.
You can put your questions to Dibyendu.
It was a very nice presentation. Actually, Dibyendu sir, I have a query regarding the CAM process, which is for the electric vehicle. It is still not streamlined, and there are a lot of R&Ds are going on.
Yeah.
So, when we can expect that? I mean, when it will be more defined regarding the CAM process, because as you can understand, it has lithium NMC also, and the percentage is still not defined.
So to answer to your question, just you're Partho, right?
Yeah, Partho.
Yes, Partharaj Ghosh.
Sorry, Partho. Partho, to answer to your question, in fact, it's not that exactly right. Maybe because there are a lot of EV manufacturing which is happening in the countries like these countries, because the percentage of EVs getting sold in the market has dramatically improved or dramatically increased, I would say. So the manufacturing processes also have improved quite a lot. In fact, the manufacturing processes, the previously what we used to see, the manufacturing processes, how they were getting handled, is now is absolutely changed. By the way, just Ashishda, just checking, if I have another 2-3 minutes, I can actually give a little bit idea about the manufacturing process itself.
Go ahead.
Okay. So part of the thing is that in a car assembly line, the manufacturing process, how it used to happen, it used to be a straight line conveyor, right? You start off with something, then plug in various parts of the car inside, then it goes to the next station, you plug in or fit some other parts, again you go to the next station, you fit in some other parts, and gradually at the end of the road, end of the conveyor belt, you will have a fully constructed car going out, right?
Yes.
That's actually the manufacturing process. But now that concept has totally changed. So it is the parts which are going around. There is no conveyor belt as such. So the car itself actually moves around from station to station, and it goes to a particular station where it needs to be fitted. So the manufacturing process has improved dramatically. It's a completely, so to say, I'm just not able to remember the term what they say, but in Daimler terms or the Mercedes-Benz, they call this as Factory 56. It's an intelligent factory. So where actually the car which is getting assembled, that's itself moves around to various stations, and picks its and informs the assembly man or the operator who has to assemble, and informs them that this has to be fitted. So it's a very intelligent process. It's not that conventional process which we used to see the previous days, or which is currently happening in a lot of plants. But there are certain plants which have dramatically improved the manufacturing process.
Actually, sir, my query was a little bit different. It was more related to the electric vehicle battery. I didn't define that actually. So, anyways, thank you for that point.
Okay.
And another query was regarding the scarcity of lithium resources. Like,
Yeah, that is a good point. That is a valid point. In fact, regarding lithium, we are completely dependent on China. And by the way, I read some reports that there is a huge lithium reserve which has been found in Kashmir or some Leh Ladakh, someplace. I forgot that name of the place, but you are right. Lithium scarcity will come into picture and come into discussion, huge discussion, very shortly, because the more the EVs getting manufactured, because battery technology is currently dependent on this lithium ion or that kind of a high power battery. So lithium will come.
Just to add one note to Partha, yes, India, we read in the newspaper that, okay, there is a huge reserve of lithium in India. But at the same time, Partha, there is a huge reserve of lithium is in Serbia. And right now, the extraction process, the project is going on. In another 2 years, the scarcity in the market, maybe little bit, it will be eased. You don't have to depend solely on the Chinese. And the contractor is working on this one for this project. The name of the contractor is another German company, DMT. Dibyendu might have heard the name.
Yeah.
Right. So it is like that. Yeah. So it is. I think with the Serbia lithium and India lithium, I don't know when and how, but if it comes in the market, then maybe scarcity will be a little bit eased.
Okay. Thank you.
I think we answered everybody's query. I'm just missing one question from Debjit. I'm repeating again. Debjit, are you here? Debjit Mandal? No. Okay. Fine.
I just want to pitch in one just small point. Hello?
Yeah, please.
Yes, please.
Yeah, I just forgot the link. The previous question was, oh my God, I just, it was on, sorry, I missed I just forgot. I was about to,
no problem.
Open the speaker. I didn't open the speaker actually. Anyway, sorry.
No problem. Let me tell you, there is a link given in the chat box. You can see, you can share your thought and feedbacks. There is a Google form.
Sure.
And in the comment section, you can write your question and you can give your mail ID. Definitely, we will get back to you.
Surely. That's a very important point. I'll let you know through the chat. Very important point for everybody.
Sure. And I request everybody to share your feedback on this presentation. And if you have any query, please write it in the comment section and put your email ID. We will get back to you. And you can separately email also to the department mail ID, apalumni.cu@gmail.com. It is also there in the chat box. You can note down these two links, and you can put your questions or your impression about this presentation, whatever it is. Yeah. So I think I overrun another maybe 25 minutes more. But thank you, Dibyendu. It is really an interactive session. And before I conclude, I'd make a request to all our alumni that this was our first tech talk. If anybody is interested in presenting a new technology or a tech talk, please feel free to contact with your email and a photo. And from our coordinator side, somebody will get in touch with you and we will formalize it. So on behalf of Applied Physics Alumni Association, I thank you all for participating in our first tech talk. Thank you very much. Mr.
Thank you, Ashish and Dibyendu.
Mr. Sudip Saha, just a minute. Sudeep Shah has raised his hand. Is it the old question or? No, I think no. Anyway, thank you very much. Thanks a lot for participating in this presentation. We hope in future we'll carry out same presentation with the same tempo for our upcoming centenary celebration for the Applied Physics Department. Thank
The
you.
presentation is quite good, quite satisfactory, highly informative, and technical aspects have been very clearly, very distinctly outlined. We are happy, and this is a very good presentation that we are here. It's a great chance for us, for me rather, and all. Thank you.
Thank you very much.
Thank you
In
very
fact,
much.
I just like to thank you all for taking your time and listening to this. And the other thing, I really it was an absolutely different experience for me with my seniors and my ex professors and all participating in that, and also my juniors. So thank you very much from my side.
Thank you.
Thank you.